Welcome all, welcome to this lab of Object-Oriented Programming 1, and let's start with our lab. Let me first show the disclaimer. Okay, so let's start now. So see this this is your syllabus as per GTU, and we will be following that particular list of experiments only suggested by the university. So there are about 25 programs in this particular list. Okay, we'll be doing those, and we'll also be seeing some more in our theory part. Okay, to understand the concepts. Okay, so the first program is write a program that displays welcome to Java, learning Java now and programming is fun. That is a simple println statement kind of hello world kind of program. Second is a program that uses an equation that it says write a program that solves the following equation and it displays the value of x and y. Okay, so these two equations are to be solved and we have to find the value of x and y, and they have said that assume Cramer's rule to solve the equation, that this and these two are the equations and this is how you can find the value of x and y. Okay, so we will be doing some expressions, arithmetic expressions in this program. And the third program is about, it says write a program that reads a number in meters and converts it into feet and displays the result. Okay, so let me first show you these three programs. Okay, let me open the okay, see, I will be sharing with you people the programs through GitHub site. So this is my GitHub site and I'll be putting up the programs over here, and you can access it from here. I'll give you this link. Okay, from here you can access the program. Take this link. Okay, and here you can download, from here you can download the code. If you click on this, you can download the zip of whole code, right? What I would suggest is you people also make a branch out of this. Okay, you people make a branch out of this particular, try to see what is GitHub and how to use GitHub. You can just learn it within half an hour from YouTube. Okay, so you'll be able to make a branch out of it and you will be able to practice it. Okay, and you can put all your programs on your own GitHub account. Okay, so here I have put my programs, and what I'll be doing is whatever changes I do, I'll be uploading through this. Okay, so you'll be getting the latest programs that we make, that you'll be getting in this GitHub account. Okay, so let me open the VS Code. Okay, so now this is first program. Okay, now this program says that write a program to display hello world, welcome to Java, learn programming, Java programming, learning Java programming is fun. So what we have done is here you can see that here I have made a class. Okay, class name can contain underscore, that's valid thing. It can also contain numbers, but it should start with a letter or maybe an underscore, but not a number. Okay, then it is a keyword is used as class and public keyword is used. Okay, so this is a public class, and inside it has got main method. We know that main method, this is the signature of the main method. This is only how we have to use it. We cannot use it something like this. You cannot say that I will use a main method like public void main. Even if you forget things like the static keyword or this argument, then that won't be the main method that will be called by the JVM. Okay, JVM will look out for this particular method signature only. Okay, so in this method, basically what do you have is public means this main method can be publicly called by JVM. When you run this program by the command java and gtu practical 001, and then when you say enter, okay, and you press enter, right? So what happens is this command invokes JVM, and JVM looks for this particular class, and in that class it will be looking for this particular method signature. So that's why it should be public, because JVM is an external entity. Okay. Then static, we know that because the JVM should not, this JVM or the Java command that is running, that should not need to make an object of this particular class. So it should be able to directly call this main method through the class name. Okay. And void is it does not return anything to JVM. And main, just to make sure that the C programmers feel comfortable with this particular programming language. So here they're also used to make use of main. Here also it is main. And here this is string array arguments, which represents the command line arguments. Okay. This represents the command line arguments. Okay. This is, even though if you don't pass any arguments, this is necessary. Okay. So in this main method, what we have done, we have simply printed out system.out.println hello world, and then we say, see here what I'm doing is, here I'm saying welcome to Java, that is printing, I'm printing it, learning Java programming is fun, that's what I'm printing, and here I'm using this new line character \n. So it will work similarly the way it used to work in C programming also. Okay. So if I specifically want to run this, then I'll say run the program, and terminal opens up and it runs. Here it is. This is how it has run. Okay. Now if we see the second program is basically to write the equation for this particular, to solve these two equations using the Cramer's rule. Okay, so we have to find the values of x and y, and we have to assume that this is how these two equations have been structured. Okay, so from first of all, what did we do is, first of all, in this particular program, the first thing that we did is, in these two equations there are some numbers given, right? So what we'll be doing is, we'll be first taking out these numbers. Okay, what we will be doing is, we'll be taking out these numbers. Check this out. So we have created various variables of type double. So you can see a equal to 3.4. This is a, and this is what, b. So this is b. Then this part 2.1 is C, and this is D. So you can see this is C and this is D, and this part is E, and this part is F. Okay, so now we have assigned all the numbers that were present in this particular equations to some variables, right? Now we are ready to find the values of x and y. Okay, so what do we do to find out x? We make the equation like this. Okay, check this out. It says, what does it say? In order to use this equation, we have to use this particular part. Check this out. Here we say x is equal to ed minus bf. Now see, this ed minus bf, this is a whole equation, so it should look something like this. ED in bracket E into D minus BF, that is one bracket, and AD minus BC, that is another bracket. Okay, and if you go much more further, then this is also one more bracket. B into C is one bracket, A into D is one more bracket, B into F is one more bracket, and E into D is one more bracket. But we don't use so many brackets when we are using this particular notation. Okay, but in programming language we have to make use of brackets, especially so that the expression gets evaluated properly. Okay, the equation that is in the bracket will get the first priority. Okay, so what happens is, here in this whole equation the first priorities are like this one gets executed first, this one, all these four get executed first, then this subtractions get executed first, and then this whole division gets executed. Okay, so this is level 1 of execution, this is level 2 of execution, and this is number 3. Okay, so this is how the whole equation gets evaluated. Okay, so you can see over here, similarly you can see over here at this x is equal to E into D is in one bracket minus B into F, and that whole part is inside a single bracket. Okay, then A into D is in one bracket, B into C is in one bracket, and that whole part, that whole subtraction inside is inside another bracket, and then comes this whole division part. Okay, so this is how the expression gets evaluated. Okay, similarly you make it for y. Okay, and then so see here what happens is, if you don't use brackets, then basically the thing is, if you make it something like this, y is equal to a into f minus b into f divided by a into d minus b into c. See, even if you have written it like this, the equation will get a quite different evaluation. So check this out. What happens is, here in this arithmetic expression, the priority first goes to multiplication and also the division part. Okay, so this would result into quite different way. So it's better to use brackets so that this division that was over here does not take place uh, in between these two, or it may even take place in between the value of this and a. B into f, the result will be divided by a, and then the result will be multiplied by d, and then b will be multiplied by c, and then this whole thing will so it will be something like this whole thing subtracting this whole thing, subtracting this whole thing. So the overall result will be totally different. Okay, make sure we make use of brackets properly while we are making the expressions. Okay, and then we find the solution. So if we run this out, okay, and so we get to see, check this out. Here it shows the equations. This is the given system of equations, and here the solution is given. This is x and this is y. Okay, so that is practical number 2. Now we come to the practical number 3. This practical number 3 basically deals with writing a program that reads a number in meters. A number is read in meters, and that number is converted to feet, and displays the result. Okay, and display the result. For example, if 1 meter is there, it should be converted into 3.28084 feet. So here in this program, what we will be doing is, here we will be targeting for the user input. Okay. Till now we have not used user input. So here what we will be doing is, here we will be taking input from user. So this is a class, and this is the main class inside which we have the main method. Okay. And here we will first, in the starting of the, when the method gets start executing, the first execution statement is, we display a message that enter the value in meters. Okay, we display this message to the user that enter the value in meters. And then what does, how do we read the input from the user? So basically, in order to read the input from the user, we use system.in. What is this system.in? This basically is nothing but, it's a, the system.in is nothing but a input stream object. Okay, it's an input stream object. So this input stream object basically refers to standard input. The system.in is nothing but standard input. Okay, and normally the most of the languages take standard input to be the keyboard of your laptop or PC or whatever it is. Okay, so the system.in directly represents keyboard. Okay, and it is of type input stream object. It's a standard input object. So whatever input we give through keyboard, right, will be can be used by the scanner class. Or we say, what do we say? We wrap an object of scanner around this. So we make that object, call that object as SC. Now this SC object, scanner object, can read many things from the console, it, or from the user. It can read specifically strings, it can read integer values, it can even read double values directly. So we don't need to read the values from strings and then convert it to integer or then convert it to double. That is not needed at all. So that's why this scanner class is very, very useful, and the scanner class is basically imported. Now this, in C language, you people used to do something like this. What you used to do something like this: hash include and stdio dot h, right? So what was this? This was a header file. Why was it used? Because we needed some statements to be used in our program. Like for example, printf function we used to make made use of. Then we also had made use of scanf functions, right? So these functions basically are available or declared. These functions are basically declared inside this header files. And so that's why we need to include this header files if we want to make use of those functions, right? Similarly, here in Java, we use import statement. We don't use include statement, we use import statement. It says import java.util.scanner. So why this big name it is? So see, this is the package name and this is the class name. What is this? Are two different things. This is package name and this is a class name. So package name basically defines what? It defines a folder. Okay. So there is a kind of Java folder inside which we have util folder, Java folder inside which we have util folder, inside which we will have the scanner class, and there can be lots of other classes. Okay, there can be lots of other classes like scanner class. Okay, inside what? Inside this util package. There can be other sub packages also under Java, right? So in Java we have this. In Java we have this util package, and similarly there can be other packages. So most common packages are like lang, then io, okay, and net for networking, okay. So there are lots of packages available in Java, okay, that we may be making use of, right? And we may be making use of the classes available, classes and interfaces available in those packages. So right now, if you want to understand what is a package, it's nothing but just a folder structure. This Java is a package inside which util is a package or a folder inside which scanner class is stored. Now, why do we need folders to represent or store these classes? Because there may be some other scanner class also in some other package. So how do you differentiate both the classes if the names are same? You differentiate it by the package name. Okay. We'll go much deeper into the packages when we start learning it, so don't worry about it. So right now just assume that we are importing the scanner class from this java.util package. Okay. And then we enter the value in meters. We say we send a message to the user by saying enter the value in meters. It reads, we say first make an object of scanner class, and then now we say sc dot next double. This next double will read the values from the console or from the user, and it will convert it into double, and that will be stored over here inside this now. It will be assigned to now. Then we can, once that is assigned, then what we can do is we can perform some operations, we perform some expression. So here we have said num into this 3.28084, whatever will the result, that should be assigned to the variable feet. So now we have converted the number that was entered by the user, which was basically in meters, to feet by putting that number into this expression or this equation. Okay. And then print it out. The corresponding value in feet is this much. So if we run this, okay, so you see here it is asking me enter the value in meters, right? So I'll say 10. So that becomes about 32 feet. You see that, right? So what I've done is, see, I would also recommend you people to do some setting like this. First of all, install GitHub. Okay. Once you have installed Git, then you install this desktop, Git desktop. Okay, GitHub desktop. And from here, see, the best part is whatever changes I make in this, it is visible to you. So check this out. Here I had made some change, right? Previously it was something like this. Now I have made something like this. Okay. Now let me just again. Now if I'm saving it, then it will go away. You see that? That change has gone away. So here I had made some changes, right? So what it is asking is, what do you want to do with this changes? So I'll simply say programs updated. That's it. And I will say commit to master. And once this is done, I will push it to the site. So here you will get to see the latest program only, right? Once that has been pushed, we'll get to see, if I just refresh this, you'll get to see that yes, these two programs were updated 20 seconds ago. You see that? So this is the benefit of using this kind of GitHub, and then that GitHub will be directly linked to Visual Studio. So whatever you edit over here, it will be caught by the GitHub, and it will be easy for you to upload it. Okay. So it's okay if you don't use this. I don't mind. You can use any IDE. You can even use NetBeans, okay, or Eclipse. Okay. So these were the first three programs. Which programs? Specifically this program for using println Then this particular program on you how to use equations, and then this program that reads a number in meters and converts it to feet and displays the result. Okay, so these very three basic simple programs we have done in this particular session. Okay, uh, fine. Let me uh, check if any other programs are also remaining, then we can take those also. Okay, any doubt till now in this program? Please let me know. Any doubt till now in this particular in these three programs? Please do let me know. Yes, guys. Any doubt at all? Okay. Any doubt, guys? I can see people are saying no. Okay. So let me see if I can show you some other programs. Okay, we had worked with this particular programs in our lecture, right? This Boolean test, where we make use of uh, the Boolean values, right? Then we had made use of this byte shift, where we shift the bytes, okay, and then we display the value. Then we also had used byte unsigned byte shift, right? And we had seen care demo, okay, and we had also seen how to read two numbers and do some expressions. Okay, so any doubt in this four programs that we had seen in our lecture? Any doubt in this five programs? Please do let me know. Yes, any concept you are not able to understand, or anything that you are not able to locate? Yes, please do let me know. Please reply, guys. I'm waiting for your reply. Okay. Okay. Only four people have just replied. Please reply fast. I'm waiting for a reply. Yes, guys. Okay, you want to understand. Henry wants to understand the Boolean program. Okay, that's good. No problem. So see, in Boolean program, what happens is in Boolean program. Let me go to this bull test. Okay, this Boolean. Okay, fine. So let me understand. Let me explain you this bull test program. In this program, what we are doing is here we are basically creating a boolean variable, declaring a boolean variable, and we are giving it some values. So first we gave it false, we printed it out. Obviously it will print false, b is false. Then we assigned it true, and then we print it out, it is saying b is true, obviously. Then if we said not of b, what is not of b? Not of b is this not b. This not b will, what it will do is this not b will convert the value of this b to the opposite value. So if the right now the b's value is true, then it will be converted to what? Then it will be converted to false. And if its value is false, then it will be converted to true. Okay, but that will be for this much period only, for putting it into here in the print ln statement only. Actual b's value will not get affected, so that's why I have directly printed b afterwards also. So if I run this particular program, if I run this file, then you will get to see that first output will come as b is false, that is right. Then the second output will be b is true, that's also right. And then we say not of b is obviously opposite of true is false, so not of b is false. You see that? And you can even assign. So see, that's why I just printed after that what is the b's value. B's actual value is true, but you used not operator method, it reverses the value. Okay. And then we can use that b in if else statements. So this is an if statement where we simply say if b, then system.out.println, and this is executed. What is the value of b? B's value is true, right? So obviously this means if true. So obviously it means the condition has evaluated to true. If does not know that there is a boolean variable, it just sees what is the value of b. It's a boolean variable, so that's why it and if also expects a boolean value, whatever be the expression, right? It always expects boolean variable, boolean value. So it gets the value as true. So since it is true, it will print as that this is executed. And then if we say b equal to false, and then we make it in the use it in a b, then we say this is not executed. Or you can do one thing, you can, if you don't assign this false and you simply say not b, okay, not there, over here in if statement we also say if not b, we say over here not b, then also that's the same. Why? Because this b is true and that not b will become false. So since it is false, this is not going to get executed. You see, this is executed. After that we don't see the output as this is not executed. Okay, then check this out. When you use that any expression, if you use any relational operator, so for example here you're using the operator like 10 greater than 9, so obviously that is the result is true. So the value gets, you get the value is boolean value. 10 is greater than a 9 is obviously this will result into true. Okay, so let me again run this. Obviously this is not executed, will not get printed. Check it out whether it is getting printed anywhere. No, it is not getting printed. This is executed, that is printed, but this is not executed, that line is not getting printed. Okay, because we have used not b. Or we can simply assign value false to b, and then we can evaluate it. Understand? Is it clear? Is the doubt clear? Yes. Okay, thank you, Anil. Any other doubt by anyone? Please let me know. Yes. Okay, so I'll stop the recording and we can have interaction, okay, on this. Any other doubts if you have, you can ask me, and I'll also show you. I'll also share the uh, code with you. And if you people are able to run it, then I would love to see your screen. You can share your screen and show me the output on your machine. Okay, so that's it.